Hello, everybody, and thank you for joining us this evening for the third week of the Rugby Research and Injury Prevention Group 2025 Journal Club. We will begin our journal club presentations, and our first intern is Nadira Peaks from Adelphi University. Nadira will be presenting on the brain study, which is a study which explores concussions and long-term cognitive function in rugby players. Nadira, whenever you're ready, may you please share your screen?
Thank you, Gabriel. Good evening, everyone. My name is Nadira Peaks, and tonight I will be discussing an article titled Concussion and Long-Term Cognitive Function Among Rugby Players, part of the brain study. This article was featured in the Journal of Alzheimer's Association in 2021. So, study overview. There is a growing concern about the long-term effects of repeated head injuries in contact sports such as rugby. This study will follow up on the original brain study that was conducted in England with retired elite rugby union players. The purpose of this study was to assess the associations between self-reported concussions and cognitive function among retired rugby players. And understanding this association may contribute to improving player safety and welfare. So the key questions that the study highlights are: is there an association between a rugby player's concussions and their cognitive function? And is there a specific number of times a player has to be concussed for there to be more of a decline in cognitive function? An overview of the methods. So this study employs a cross-sectional design and involves the recruitment of former participants from the original brain study cohort. These participants include 146 retired elite male rugby players, all over the age of 50 and based in England. The data collection tools that were used in the study are called the Brain Q questionnaire tool, which will self-report concussion history, and the preclinical Alzheimer cognitive composite, or the PACC score, that will evaluate cognitive function across multiple domains. So the Brain Q tool, as I said before, is a tool for assessing self-reported sports-related concussions for epidemiological studies. BrainQ has three-stage processes. One is defining a concussion, two is creating a visual timeline with life events, and three is establishing detailed characteristics for each reported concussion. The participants in the BrainQ questionnaire will determine the number of concussions they have experienced. For the preclinical Alzheimer cognitive composite, or the PACC tool, it is a standardized cognitive assessment tool designed to detect subtle cognitive changes associated with early Alzheimer's disease. The components of the PACC consist of the total recall score from the free and cued selective reminding test, the delayed recall score on the logical memory 2 subtest for the Wechsler memory scale, the digital symbol substitution test scored from the Wechsler adult intelligence scale revised, and the mini mental state. So these four components are all standardized assessments that when combined together, you can get a single score, which is the PACC score that will evaluate the cognitive function of players. For the statistical analysis in the study, descriptive statistics were employed to summarize the data set. On the left over here, we have a graph titled Length of Rugby Career by Concussion Categories. It features a study that shows rugby players, the brain study rugby players, split up into three categories. The first category is no concussion, the players that reported no concussion, the players that reported a low concussion, 1 to 2 concussions in their career, and the players that reported high concussion, which is 3 or more concussions. On the y-axis, we have the length of the career, and as you can see, the three subgroups, they all reported having, or the median is 15 years for the length of their career. On the right side, we have the preclinical Alzheimer cognitive composite by age group, which splits the brain study participants into four age groups: 50 through 59, 60 through 69, 70 through 79, and 80 through 89. And we have the total PACC score that they scored. A -3 means a lower cognitive function, and a 1 means a higher cognitive function. So inferential statistics were also used to examine the relationships in the study. A linear regression model was used for the analysis of the PACC scores. Concussion density and the career length were the main exposure variables. The model was adjusted for potential confounders, including but not limited to age, but related to 10-year bands and concussion history. So the restricted cubic splines test was graphed as an additional analysis. An example of the restricted cubic splines test can be found on the right-hand side of this graph over here. It's This test checks whether a relationship between a variable and outcome is nonlinear. And as you can see with the nonlinear lines over here, it is not linear. So for the results of the study, out of 146 participants in the study, the mean length of each participant's career was 15 years. And using a statistical analysis mentioned above, this study has found no association between the concussion and the PACC score. However, the participants aged 80 years or higher reported 3 concussions or higher were proven to have worse cognitive function than those without concussions. In this discussion, we can ask, what can we interpret from the study? The brain study has found that there is no correlation between the concussions of elite rugby players and long-term decline of cognitive function. The brain Q tool that was used to calculate the number of concussions from the participants is potentially susceptible to recall bias. A rugby player who is 50 years or 59 years old may have a better recall of their concussions versus a person who is 80 to 89 years old with deteriorating cognitive function. However, this recall bias is unlikely to change anything in the association between the concussions of elite rugby players and the long-term decline of cognitive function. So to reiterate, in conclusion, the study did not find any evidence of association between rugby-related concussion and cognitive function. However, a significant interaction with age revealed an association in older participants who reported 3 or more concussions. These are my listed references, and are there any questions?
Right. If there are no questions at this time, then I would like to move on to the next presentation. Dr. Lopez, I don't know if you have to say something.
No, I just wanted her to go back to the references a moment.
All right, thank you again, Nadir, for your wonderful presentation. It was really, really insightful and interesting. I'd like to now introduce our second intern, which is Violet Torres from Ithaca College. Violet is going to be presenting on high concussion rates in student community rugby union players during the 2018 season. Violet, whenever you're ready, could you please share your screen?
Thank you, Gabe. As Gabe said, I will be discussing the high concussion rate in student community rugby union players during the 2018 season, implications for future research directions. This study was found in the Frontiers in Human Neuroscience in 2019. So some background on the article was that rugby union is a collision sport with a high risk of injuries, especially concussion, due to the negative cognitive short and long-term effects, of course. My second point is, despite most rugby players being non-professional, little research exists on injury rates in this particular group. And the Stellenbosch University's rugby club, one of the world's largest amateur clubs, was the ideal cohort used to study injury patterns in non-professional players. The purpose of this study was to describe the incidence and causes of concussions among non-professional student rugby players during the 2018 season at the Stellenbosch University, and it was also to inform future strategies for reducing concussion rates through detailed analysis of when and how they occur. So some of the methods used were that there were 807 male student rugby players, and ages ranged from 20 to 22 years old, and this study was based in South Africa. The duration of the study was 10-week tournament in the 2018 season with 101 matches played. As for the data collection, injuries were recorded by trained medical staff using a standardized electronic form, as well as only match-related time loss injuries being analyzed, which is just the injuries that prevented players from future matches or training. And these are both pulled from the consensus statement, as well as concussion detection, which is just which is based on the recognize and remove guidelines, which is the idea that if they suspected any type of symptoms or signs of concussions, they would just immediately remove that player from the match. Here I have tables as a visual representation of what the results, which I will discuss in the next slide, of the study were. In the first table, table 2, you can see the match-related time loss injuries by body region. You'll have the head and neck being 44% proportion, upper limb, lower limb, both at 28%. And for the table below that, you will see the phases of play associated with overall match injuries. Here you'll see the types of ways match injuries happened, as well as the injury count and injury rates side by side. And here are the concussion injury counts and injury rates. The study primarily focused on the injury rates for both overall time loss match during the match and as well as concussion match. Here is the injury rate. There was 30.6 injuries per 1,000 match hours, and the concussion rate was 9.3 per 1,000 match hours. Concussion being the most common injury, which is where this study was primarily focused on. so they didn't really mention too much of everything else, but they did include it in the study. The most frequent concussion causes were tackling being at 33%, accidental collisions being at 30%, and being tackled at being at 11%, which we saw in the previous slide. Concussion rates in this study were much higher than in previous studies from the UK and USA, which are both mentioned in the article. Head and neck regions were the most common. Compared to the similar cohorts as mentioned before, the concussion rate in this group was significantly higher, about 6 times of that than the other studies, and this is potentially due to the improved detection and stricter protocols that this study enforced, being that the recognize and remove guidelines that they were using. So why is this important? This highlights concussion as the leading injury in non-professional rugby. So knowing that concussions make up 30% of injuries in student rugby shows us where to focus prevention efforts. It's also useful to bridge into different age groups in order to compare the data. It also identifies limitations in current injury surveillance methods. So this highlights gaps like the lack of individual match tracking or video evidence, giving us clear direction on how to improve data collection in our own research, which we are already improved on because we are going to be using video surveillance. My third point is showing how report standards and protocols affect data. This encourages us to be cautious of when comparing data sets and to consider how concussion definitions, reporting procedures, and medical training influence the results. My last point is recommends actionable next steps, being video analysis and long-term monitoring. So these are simple additions to add to our own research that could help us understand injury mechanics and design more targeted prevention strategies. Some key takeaways are that this study reflects better awareness and detection rather than actual increase in injury frequency. The protocol used makes it seem like there are more reported concussions than there actually is. Future research should incorporate video analysis to better understand how these injuries occur and to design targeted prevention strategies. So without the injury surveillance, it leads to making assumptions, which doesn't help in validating data. And the last point is concussion education programs should be improved and their effectiveness evaluated, given that the injury is 6 times higher than compared to data collected from the studies in UK and USA. This creates a concern and therefore requires some level of education, which may include improved tackle technique training, modified gameplay rules, or enhanced protective measures. Some limitations of the study was that there was only 1 season that was analyzed, which is not long enough for us to determine any long-term trends. Like I said before, some estimates were based on assumptions, not individual player data. An example of this was exposure time. There was no information on the individual matches that 807 of the players played. And going into my third point, there was no tracking of which specific players participated in which the matches, which is because there was no evidence to prove if all of them even played. And the fourth point is external injury reports might have been missed. Example, players seeking outside medical care. There was mentioned in the study there was a fee for service in the university's medical services, so that could have played a part in whether they went elsewhere to seek medical care. And these are my references. Does anyone have any questions?
Hi, Violet. This is Philip, a rising sophomore at the University of Michigan. I'd just like to add maybe a comment, more than a question, but to add on to your takeaways from that. It looks like, according to that study, the recognize and remove tactic was pretty successful in identifying concussions that are otherwise not identified in other leagues or countries, as you could see by the rates that they found. I think that that's also sort of evidence in support of the blue card that Dr. Lopez actually was talking about. It was either last week or the week before that was implemented into some rugby leagues, like in New Zealand. So I think that that's a very interesting piece of evidence that could support that rule change in rugby.
Thank you.
Does anybody else have any more questions? If not, then we can move on. Thank you, Violet, for your wonderful presentation. That will conclude our call for today. We thank you, everybody who joined us for the Rugby Research and Injury Prevention Group, the Group Journal Club. Thank you all for attending.